Okay, continuing with chapter 11, we have just looked at this, at null hypothesis. This is the necessary step in Anova. It states that the means are statistically equal, that all the mean values for tensile strength measurements are the same for all four suppliers. We have just reproduced this scatter diagram, which is in fact 4 scatter diagrams, and we remind ourselves that we're dealing with 20 parachutes. 5 parachutes were woven for each group. 5 parachutes for 4 groups will give us 20 measurements. This is the way the data were supplied by the authors of the book on the CD. It's right here. Right here. They also calculated the means for us. The Excel function for calculating the mean is average. And this is what we just saw here on page 246. I believe it's page 2, yeah, 426. This is the typical layout of the Anova table which we're going to reproduce. All this information up to here just shows the steps which were used to come up with the F ratio. What we need to do is to determine whether these sample results are sufficiently different to conclude that the population means, and once again, populations in this chapter are groups. These 4 groups, those are the populations. Sample results are sufficiently different to conclude that population means are not all equal. We've just done this. We're looking at the alternative hypothesis. It quite simply states not all the means are equal. It's possible some means could equal to each other, but out of 4 means not all are equal. We're going to calculate grand mean, which is used in the calculation of the sums of squares among groups. We have 4 groups. 5 parachutes went into each group. We need the grand mean, which is basically the sum of all the measurements divided by the number of measurements. We did it here in Excel. Grand mean, we're going to redo it. Sum of all the values. We should be very glad we're not using any units here because it would be ridiculous. The units for tensile strength, that's pound-force per square inch. We cannot add them like this, but in statistics we can. These are our sums, and over here the value that was used in the calculation of the grand mean. 438.9, let's save this. 438.9, this is the number of measurements, which is the number of parachutes, 20, grand mean. In calculating sums of squares among groups, we are looking at the deviations of the individual group means from the grand mean. That's the same number over here. The deviations are squared and summed up, multiplied by the number of parachutes in each group. In this particular example, we have 5 everywhere. It could be different. 5 everywhere. Sums of squares within groups, that's inside group variation. That will show the deviation of each individual value from the individual group's mean. We have 4 means: 19.52, 24.26, 22.84, and 21.16. They're all right here. Come from here. So far so good. We have gotten the total variation, total sum of squares value for 160. We just added these two for verification. Okay, 63.2855, 63.2855 plus 97.5040. 97.5040, just to illustrate. This is an acceptable operation in statistics. If you think for a second about units, this will not make any sense, but this is fine as long as all the units are the same. So we have gotten ourselves the numerators of the variations which will be used in the calculation of variances. Variances are mean squares. Mean squares are variances. And by the word mean, we mean that we're going to have to use the numbers of measurements in the denominator, but for ANOVA there will be the degrees of freedom, not just the numbers of measurements. The degrees of freedom between four groups, or among, as the authors of this book like to say. That's 3. 4 groups will allow the value to vary 3 times among them. This is the SSA calculated on the previous page divided by 3, 21. And this is the variance for within the groups inside them. We have 20 groups, 20 measurements, and 4 groups, 6.094. Here comes the F statistic. F statistic comes from the F distribution which we discussed in the previous clip. It has to do with the probabilities of the ratios of variances occurring in a series of measurements. We're going to have to compare the obtained F value right here against the critical value from that very distribution I just mentioned. Under normal circumstances, the table value would be called critical value, which they say here, right? Critical value, and will be FCV. They call it F sub U here, so we're going to have to stick with that. First, we select the numerator. In the numerator, we have MSA, among groups. We're going to have to remember the degrees of freedom to vary among 4 groups. There will be 3 degrees of freedom. For 20 measurements grouped in 4 groups, we have 20 minus 4, 16 degrees of freedom. And here is our critical value, 3.24. This shows us that the critical value creates the region of rejection within which the calculated F ratio easily lands, 3.4616. That's right here. To the right of the critical value of 3.24 lays the calculated value of 3.46 in the region of rejection. Therefore, we can easily reject the null hypothesis right here. We now know, we conclude that there is a significant difference in the mean tensile strength among the 4 suppliers. Before we proceed with ANOVA further, we have to put all this in a summary table for ANOVA. And Excel will also calculate the p-value for us. In the ANOVA, in Excel's ANOVA summary table. Let's stop here before recording a new